Take two children of the same age and expose them to a simultaneous immune trigger, like a routine vaccination or a common viral infection. One child processes the impulse without incident. The other suffers a severe neurodevelopmental regression, exhibiting aggression, tics, or sudden sensory overload. Clinical models often struggle to explain this collapse, frequently assuming the underlying neurological hardware has sustained permanent damage. This behavior aligns with a systems engineering phenomenon called the hysteresis latch, a state where biological logic gates become locked in a defensive, high-gain posture. Determining why one system crashed while the other held requires analyzing the hidden state of the hardware in the months before that impulse arrived. This hidden baseline is established deep in the gut microbiome, which functions as the body's primary logistics hub. When this hub falls into dysbiosis, it continuously leaks dirty current into the neural bus, biotoxic metabolites like lipopolysaccharides and propionic acid. This influx of biological static pushes the internal noise floor toward the brain's absolute voltage ceiling. As this gap closes, the microglia remain constantly primed. The system burns through its voltage headroom, losing the capacity to process new information. A child in this state can appear typical, yet they are biologically sitting on a powder keg, lacking the bandwidth to handle any additional immune load. In engineering terms, a viral infection or a vaccine is a high-energy data packet, an impulse event designed to train the immune system's security logic. In a healthy system with high voltage headroom, the hardware absorbs this impulse, updates its database, and returns to equilibrium. If that same high-energy packet hits a system where the noise floor is already touching the ceiling, the reaction changes. Through constructive interference, the underlying gut noise and the new immune impulse add together. Their amplitudes multiply into an unmanageable monster wave. Physical ingredients in vaccines, like aluminum adjuvants, can act as inorganic interference here. They can clog the brain's astrocyte vacuums, preventing the system from cooling down or clearing excitatory static. The trigger event is rarely the primary cause of a regression. It is the final surge that breaches the threshold of an already overloaded system. When that massive combined wave finally breaches the maximum voltage capacity, the fragile system suffers a complete, catastrophic signal saturation. This internal electrical clipping translates into external behavior, like sudden meltdowns, repetitive physical stimming, and total sensory overload, as the processor loses the ability to separate signal from noise. Completely overwhelmed, the brain executes an ultimate defensive mechanism. The microglia flip into the aggressive M1 attack state to protect the core infrastructure. Long after the initial virus or vaccine has cleared the body, the circuit stays polarized. It remains physically latched in this high-gain defense mode, unable to reset. The child is now trapped by their own security system. The biological memory of that shock becomes their new baseline, causing the processor to treat normal environmental inputs as severe threats. Shifting from forensic analysis to proactive engineering involves evaluating the system's baseline before introducing new impulses. This is the microbiome readiness score. It is a 10-point diagnostic metric determining if a child's biological logistics can handle an upcoming immune load. Calculating it requires observing optimal stool consistency, neutral odors in sweat, and the absence of baseline systemic jitter. If the score is low, indicating active dysbiosis, a new immune load should not be introduced until the logistics hub is stabilized. In a stable system, caregivers can preload the hardware. Administering a biological heat sink, like NAC, prepares the system to safely absorb the thermal noise of the incoming immune response. Establishing this baseline resilience increases the likelihood that the system maintains the voltage headroom required to process a surge as a routine update. For a system already locked in a hysteresis latch, the challenge is different. How do we repair the state of the circuit? The protocol is the active flush. This is a coordinated hard reset designed to strip biological interference, like pathogenic biofilms, completely out of the gut. Because clearing these pathogens releases a surge of internal noise, we pad the signal with compounds like inositol, widening the brain's processing bandwidth during the transition. Once the dirty current stops, we use a final system override. Targeted biological agents are deployed to manually turn down the systemic gain. prompting the microglia to drop their defenses. Breaking that latch returns the neural bus to laminar flow. Signals process smoothly, sensory inputs are organized correctly, and the system finds a state of peace. Neurodevelopmental regression is a systems failure, a biological hardware crash that can be predicted, debugged, and reset by lowering the internal noise.